VPs de la empresa Medallia, bueno, donde están en este momento. Antes que nada les quería agradecer a todos ustedes por la participación de hoy y al equipo de Ladies por otra vez tenernos en cuenta. Nos encanta poder participar de todo este tipo de eventos, así que bueno, muchísimas gracias. Thank you, Jenny, for being here today. It's amazing to have you, and welcome. Y bueno, muy brevemente les voy a contar un poquito sobre qué es Medallia. Medallia es una empresa que se dedica a hacer Customer Experience Management, que en términos sencillos es el análisis de un gran volumen de datos de feedback de clientes de otras empresas. Quiere decir que trabajamos con empresas que quizás tienen más de una sucursal o que tienen distintas sedes alrededor del mundo, y lo que tratamos de hacer es darles un reporte de todo el feedback que va entrando a las distintas sucursales para que ellos en tiempo real puedan ver qué está pasando en cada una de sus oficinas. Si tienen un problema con un cliente puedan solucionarlo en ese mismo momento y no 3 meses más tarde. Así que después, si quieren charlar un poquito más sobre qué hace Medallia, los invito a que lean un poco más en la página, que es medallia.com, o yo voy a estar durante todo el evento, así que también pueden acercarse a conversar conmigo. Y bueno, Medallia es una empresa global, nuestra sede está en California, y todo lo que es producto y el desarrollo del mismo se hace casi un 50% acá, me animo a decir un 45% acá, el otro 45% en San Mateo, y después en Washington y en Tel Aviv tenemos el otro 10% repartido. En Argentina no tenemos ningún tipo de servicio de ventas, sí a aquellos clientes internacionales que tienen sucursales acá, sí, pero no es más que nada el desarrollo del producto. Así que no les robo más tiempo, chicas. Bueno, bienvenidas y bienvenidos a todos. Estamos muy contentos de estar acá de vuelta y de tenerla a Jenny. Tengo algunos anuncios para hacerles. Venimos de una semana súper movida, ahora les contamos. Pero primero algunos anuncios. Creo que hay muchas caras conocidas y seguro ya están en nuestro Slack de Ladies Buenos Aires. A las que no, las invitamos. Es un espacio para compartir, intercambiar información, dudas, cursos, cualquier cosa ocurre ahí. Hay muchas ladies, no solamente de Buenos Aires, sino de toda Argentina, porque incluimos a las ladies de otras provincias, así que súper invitadas. Y además hay otro Slack de R-Ladies, pero es global para cualquier R-Lady de todo el mundo. Y si bien hay muchos canales en inglés, también hay otros en español y está buenísimo para conocer e interactuar con mujeres que programan en R de cualquier otro lado. Otra invitación, hace poco se lanzó una iniciativa desde R-Ladies Global, es una cuenta de Twitter que se llama We Are Ladies. Es un sistema bastante especial, yo no lo conocía. Una vez por semana, una mujer se hace cargo de esa cuenta y tuitea desde su punto de vista, con sus con lo que hace, con lo que le gusta, y nos da como una idea, un pantallazo de ella. Y está buenísimo para que lo sigan, porque todas las semanas hay cosas súper interesantes y variadas, pero también, si alguno se anima, puede proponerse para estar una semana a cargo de la cuenta. Y creo que hoy o ayer, o hace muy poquito, Data Camp lanzó un programa para dar becas a R-Ladies, así que si a alguna le interesa puede aplicar, está buenísimo, hay cursos de todos, no solamente de R, y son muy buenos.
Son 3 meses gratis de DataCamp Premium Full Access, así que creo que vencen las presentaciones el 1 de octubre y hoy a la mañana lo retuiteamos desde la cuenta de Twitter de R-Ladies, así que supongo que va a aparecer en Facebook. Nos olvidamos de darle la bienvenida a toda la gente que está en el streaming. Hace un rato había como 15 personas del otro lado, así que muchas gracias por... ¿Dónde Hola.
Que está acá en el medio.
Bueno, gracias por sumarse a distancia, bienvenidas o bienvenidos. Bueno, contarles por qué venimos una semana... otro detalle, vamos a estar sacando fotos y haciendo algo de tuiteando las fotos, quizás, si logramos combinar 2 ideas seguidas, las organizadoras de Buenos Aires. Entonces, si alguien no quiere aparecer en la foto por la razón que fuera, no nos importa la razón, pero avísennos, así no los escrachamos a nadie. Tenemos un código de conducta, ya saben, esto tiene que ser un espacio seguro y protegido, así que cualquier incomodidad con cualquiera de las organizadoras de Buenos Aires, que les pido que levantemos las manos porque no tenemos nada para identificarnos, con cualquiera de nosotras, se acercan, nos dicen y vemos cómo lo arreglamos. Y ahora sí, venimos una semana muy movida porque lunes, martes y miércoles fue Latin R y nos acompañan acá mis cocheas, Nati da Silva de Montevideo, Riva Quiroga de Chile, de Santiago, y tenemos allá a Vilma de Lima, y me estoy olvidando de... Bea está llegando, que es organizadora de Ladies Madrid. Nos juntamos unas cuantas ladies de toda Latinoamérica. Bueno, Jenny, you're an art lady, right? Una de las art ladies referentes que nos vino a visitar y que, bueno, que a pesar de haber dado un tutorial, una charla plenaria en Latin R dentro de las jornadas argentinas de informática e investigación operativa, está acá hoy dándonos un meetup. Así que estamos como muy felices por todo lo que pasó y por conocer a mucha de la gente. De hecho, nos conocimos el lunes en persona, todo se organizó de forma virtual. Así que estuvo genial. Si no pudieron estar, muchos de ustedes han estado, otros no han podido, pero pueden, gracias a Mauro que hizo todas las fotos y a un equipo de redes sociales que no estoy viendo a nadie acá, pero Florencia de Andrea, Daniela Vázquez desde Montevideo, Roxana, no me acuerdo tu apellido, perdón, y ¿qué? Villafani, gracias, Roxana Villafani del Capítulo de Resistencia Corrientes y Patricia Loto de Resistencia Corrientes, que las dos ya están en viaje de vuelta a su casa. Esas son las voces detrás de este hashtag, que bueno, está todo ahí. Así que pueden, y vamos a estar publicando las presentaciones. O sea, si se lo perdieron, lo encuentran por ahí. Y bueno, las dejo ahí. Hubo un anuncio al final.
Bueno, ¿qué más decir? Contenta acá de estar en mi primer R Ladies Buenos Aires. Es lindo ver, soy de Montevideo, es lindo ver qué es lo que pasa del otro lado del charco. Bueno, no vamos a poder competir porque Jenny vino acá, pero no va a ir a Montevideo. Vamos a tener que ver cómo. Pero bueno, sí, como dijo ella, fue una semana re intensa con Latinar, estuvo muy bueno. Y esperamos verlas el año que viene, que Riva nos va a contar a dónde va a ser Latinar y qué es lo que va a pasar. Digo, si querés, Riva, ¿no? Digo, Riva, ¿nos querés contar?
Hola, también muy contenta de estar acá en mi primer meetup fuera de Chile. Y bueno, la invitación es que Latinar 2019 va a ser en Santiago, así que van a tener que cruzar la cordillera, así que las esperamos allá. Yo creo que en un par de meses vamos a empezar a anunciar la fecha exacta, los invitados, cómo participar, así que estén atentas porque las vamos a estar esperando. Y lo que es muy importante, gracias a esta primera experiencia ya tenemos 2 sponsors confirmados. RStudio nos va a seguir apoyando para la próxima edición, y DataUC, que es como el centro de datos estadísticos de la Universidad Católica, también dijo que nos iba a apoyar el próximo año, así que vamos muy bien encaminadas.
¿Y si conocen alguna empresa?
Y si alguno de ustedes participa en alguna empresa que quiera apoyar una iniciativa liderada por mujeres y que trata de desarrollar, que R se desarrolle en la región, avíseme, nos va a interesar mucho hablar con ustedes.
And without more delay, it's my great, awesome pleasure to introduce Jenny Bryan today in our meetup here, and she's going to be showing us and teaching us with a hands-on tutorial on how to write functions. Thank you very much, Jenny, to be here. She's a software engineer at RStudio, but before that, she's a doctor in statistics from Berkeley and had tenure at University of British Columbia as a professor for 15 years. So she's great. Thank you very much.
Thank you, everybody. Just to let you know, I hope this will be quite informal. So if you're not happy with your seat, you should move or find a power cord or interrupt me at any time. I actually would appreciate some interaction so that I know I'm not boring you to death. And so I'm wearing this mic so that the people on Zoom are hearing me, and then it also appears to be amplifying me in this room. And I have prompts for myself on my phone, so I'm not checking Twitter when I'm scrolling. That's actually related to our content. So I am going to talk about writing functions, and part of what I like about this content for a meetup is I feel like it works for a variety of people. So if you're pretty new to R, maybe you haven't written a function before, you should get this and you will leave knowing the mechanics of how to write a function. But if you're more advanced and you've been writing functions, there's also a lot we can talk about, even using really simple functions to talk about function design and then how that relates to package design and creating an interface. So I will try to sort of hit both levels as we go. And at some point I'm going to sit down and I'll only be live coding. So I have a very short few slides at the beginning just to get things started. So I don't know how well you can read this. But you don't need to install anything assuming you have R, but I assume that's true. But just to give you a sense, you know, I'm running R 3.5.1 and you don't need anything quite that current. But I would tell you just as advice that if you're below 3.4, so if you're at 3.3 or something, it's time to upgrade. You're gonna see me working in RStudio. I don't think there's anything I'm doing that is RStudio specific, but so I'm working in RStudio preview 1.2.907. And again, I like people to just at least be nudged to keep RStudio current if you use it. And so the preview versions, if you Google RStudio preview, they're very stable. They're meant for a lot of people to be using. A lot of people think they need the stable release, but it's quite safe for the general population to use the preview version. And a lot of people even use the daily version. So every day you get and I don't do that, but so you'll see if my RStudio appears to do something that yours doesn't, that might be it. And then a package we will use incidentally is the Gapminder package. So if you don't have that installed, it would be great if you did install it now. So that would be install.packages Gapminder. Hopefully people, I'll remind you, it's Medallia guest, and then the password is this, but where instead of the E, it's a 3, and instead of the A, it's the @ you could get by just doing very similar stuff with Iris or something, but it's probably easier to follow me if you have the Gapminder data. But that's just what we're practicing writing our function. We're going to practice executing our function with Gapminder data. I may call a function in a package in the tidyverse at some point, but I don't plan to actually. And at the very end, I'll probably write a test, and I would be using test that if you wanted to install it. But we have a lot to talk about for 2 hours. So, you know, we may not get through all of this, and I'll be able to point you to where it lives online. Because this is basically a live version of some lessons I have online. And again, I'll show you all the links before we're done. And then I think maybe halfway, we should pause during one of the exercise sections for people to work on that and get more to drink or get more to eat. And you're welcome to get up and get more food or drink at any time. Like it should be that informal. Oh, one more announcement.
Si tienen alguna pregunta en español y quieren que la traduzcamos para Jenny, también no hay ningún problema.
Yes.
Spanish.
Yes, feel free to stop. And I think we're small enough that unless you think it's a really peculiar question to you, you should state it for the group, because if you're confused, I guarantee you like 3 other people are. So don't be shy, it's actually a service. So if you wanted to install any of those and you're on the Wi-Fi, this is how that would go. So, and I will show this again before you actually need it, but you might want to try to go here now. So this This is deliberately short enough that you can type it. So the way I do live coding is I will actually be working in a script on my computer that lives on Dropbox. And this link will expose you to that R source file. And so every time I save, in theory, it will update, and I will try to save often. It's a reflex anyway. And so that means if I type something and you'd rather copy what I type and paste it into your script, or you get behind or something, you'd always be able to literally copy paste from me. And it also means at the end of the evening, it'll have absolutely everything that I've typed. And so you'll see right now, it's actually contains stuff I typed on Monday. I was teaching a per workshop, so you'll see me reset it live. And that also means at the end of this workshop, you know, you should take a snapshot soon-ish. I'm not teaching again anytime soon, but it won't be there forever, but it'll be there for a while. And I'll show this link again. Okay, so I have a very short intro before we start writing ourselves. And if you were at the workshop on Monday, this is gonna look familiar because it's a very similar setup, but then we're gonna get to a fork in the road and we're gonna go the other direction this time. So I wanted to motivate why would you want to write a function. And the main reason is that there are some risks with copy paste. You can do like, Hadley actually says you're allowed to copy paste 3 times, and then you have to write a function. As soon as that 4th paste happens, it's time to write a function. So I have an example to try to scare you a little bit. And so what should you do instead of copy, paste, 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 paste? I think you should learn how to write functions, which is what we'll do. And then once you know how to write functions and you feel comfortable with functions, you can drop those into machines that we have that will iterate for you. You could use them inside for loops, but even nicer is to use them inside of dplyr and per and the apply functions, because R has a lot of pre-written machinery to help you do something over and over and over and over and over again. And then you can write a function to describe what something should be, and then we'll practice. Okay, so we are not doing practice with per, we are writing our own functions. So this is an example. None of us have to run this right now, but we're gonna be using the Gapminder data to practice on. So if you've never seen this data set, it's a little excerpt that I took out of this website called gapminder.org. And it has about 1,700 rows. And for many, many countries, like 142 countries, we know what continent they're on. And then for several years, we know life expectancy, population, and GDP per capita. So for example, we have lots of data from Africa for some reason. I think maybe there legitimately are more countries in Africa, or they're better covered by this data set. But so this just gives you a sense of there's data from 5 different continents. And again, this is just getting you familiar with the data set because you're going to look at it a lot tonight. Each line on this spaghetti plot is a country, and it's showing you the evolution of life expectancy in that country from 1952 to 2007. So there's 142 lines there. This is another way of looking at the same data where you can see some sort of average trend per continent. Okay, so let's say you're going to analyze that data a little bit yourself. I'm going to ask you, if you can see it, hopefully, if not, if you should come up closer. I'm going to ask you to look at this code in just a moment and try to figure out, I want you to try to figure out what is Jenny actually trying to accomplish? Because it's got that total ring of copy, paste, 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 paste. Am I actually doing what I want to do? I will give you a hint, no. I have a few mistakes in there. I think I know what they all are. I have done this at times and people have found mistakes I didn't know about. So I'm gonna give you a minute to scrutinize that and try to figure out where things went wrong a little bit. And you're welcome, you're encouraged to discuss that with the people around you and see if together you can find all the mistakes.
Ah, está bien. Claro, se le quedó pegado de no sé.
Should I tell Hernan to mute his microphone?
Yes.
Okay, that was about a minute. So will anyone volunteer to point out some of my mistakes? Don't be shy. Yes.
There's an inconsistency. Europe, Oceania, and the last one.
Exactly. So, so when I'm trying to get the, so for Oceania, which is what we call Australia, New Zealand, when we have to talk about them like they're a continent, I'm actually taking the maximum of Europe's life expectancy minus the minimum of Oceania. There's another one of that nature. Which one is it? Asia. Yeah, we've got some more confusion. In Asia, I'm taking the max of life expectancy for Asia, but I'm subtracting the min for Africa. It's always like the one before, right? Because it's the copy-paste workflow also means you need to go through and make a lot of little changes, and the chance of you doing that correctly is 0. And then there's one more mistake-ish.
And typo in the continent.
Yeah, this, what happened to the Americas? I forgot them. And so again, but why did that happen? Because I was gonna have to sort of, making yourself retype things is generally a recipe for problems. So let's go, I'm gonna execute this just so we can be more frightened. This is also a good chance, oh right, it's hard to move between these things. Okay, hold on. Let me get this projecting. I'll turn on mirroring for a moment. All right, this is a good chance also for me to get it's pretty big. Okay, so I'm restarting R, and code that I need to run first is library gapminder before this is gonna work. I'm not putting this in the live code, but I will put everything else there. So I'm gonna just execute this line by line. I'm making my mistakes. Nothing's going wrong, right? There's no errors, right? The only time I get a hint that something might be wrong here is at the end, where I am warned that I've column bound something. I know it's a length 4 and something with length 5, but you know, R just cheerfully starts recycling, and we've got Africa there twice. Several of our numbers we know like don't make any sense, right? Because I subtracted the wrong thing. But my point is, you know, R is not going to tell you that you've made a mistake there. And so there's a lot of dangers with copy paste code that you can create mistakes that are not obviously mistakes. And so then you can also imagine that was just 5 continents, but I have seen student code doing this sort of thing like for every country, you know, people copy pasting on grandiose scale. And so it just breaks, this also doesn't scale. If the mistakes don't worry you, you should also worry about the fact that it simply won't scale when you have to do things lots of times. So one way to do this particular exercise is if you use the tidyverse and dplyr, you could group that data set by continent and then use the summarize function that will compute one thing per continent. And you can tell it, take the maximum life expectancy minus the min, and it will do that loop for you. The one that's going to set us up for what we're going to do the rest of the time is I could define my own function, MMM, for max minus min. I could define it outside of my dplyr call and then use it inside summarize. And so that's what I mean by if you write your own functions, you can drop them into dplyr summarize and the apply functions and per if you were to use that package. And so you're letting dplyr in this case do the looping for you, but it's going and doing your personal little function, and that's very nice. So why would you write functions? You can replace very repetitive, probably mistake-ridden code with less code, more readable code, safer code. You can take advantage of these iterative helpers. And eventually, this is necessary to reuse your code in a package and make it available to yourself across many projects or make it available to other people. So now I'm going to sit down for good, and I will go right into this document, and we will start doing this ourselves. Yes, okay. Okay, so I don't know if I can make the font much bigger and we can still see things. So is this acceptable to people? It all works? Okay, so I will be working live in the upper left. Pretty soon it will have a little more in it, and then I'm using keystrokes to send my code down to the R console, and the results will be showing up down here. And if you want me to try to change size or layout, again, like we can try it and see if that works. Or if you'd prefer dark. Okay, all right, we'll try this. So we're gonna change live code from function writing workshop at our Ladies Buenos Aires. This is all front matter that is boring. All right, bye-bye per workshop. Okay, so we should be able to see that now. Let's just make sure it's working. Okay, so you should be able to get this file, if you want to, up in your browser. And as I save, it's going to get longer. And here's a little warning. And it means you'll need to refresh, right? But at some point, there's a very perishable token in this URL, and the token will expire. And you'll need to refresh from the bit.ly Jenny live code, and it'll be a new token. So don't be surprised if 20 minutes or 40 minutes into this, you refresh and it doesn't work. You'll have to do the bit.ly link again. Okay. And again, do not be bashful to call someone over to get you unstuck on something. Okay, so in addition to giving like mechanics of how to write functions, I also really want to show sort of process and workflow, because that's the best thing about doing stuff in person is that, and you can see me make a mistake and try to recover and fix it, right? You never get that in a book. You don't get to see how someone actually works. Okay, so I'm going to save and I'm going to restart R. I'm not talking about workflow today, but I restart R all the time. So I have a fresh R session. I have an empty environment. The only packages I have loaded are the very basic ones that I always have loaded. And so we're going to explicitly load Gapminder, simply because that's the data set I'm going to practice on. And otherwise, we're not using any packages. Okay. So the first thing I want you to do, and this is going to be an assignment, and I'll be working on it too. If you get stuck, you can look at me, is play with some top-level code to get maximum life expectancy, minimum life expectancy, and max minus min. And so I also want to be showing you that most people don't just sit down and write a function, or when they do, it doesn't work, and then they have to go back and do this step anyway. So there's the playing with top-level code, and in a small example, until you get something that actually works. So we're going to take about a minute or two now, and I will be doing it at the same time, okay? So this is where you remind yourself of the functions you know that seem to have something to do with this. So I'm going to stop talking for a bit while we can all work. All right, I'm going to start talking over this a little bit. But so what I typed here is I started to remind myself of functions I know that take summary statistics for me. So min, M-I-N, applied to the life expectancy variable in Gapminder is a shockingly low number, actually. So this means there is a country and a year where the expected life expectancy was less than 24. So it turns out, I've looked at this data set a lot, that's from Rwanda during this year where they had like a genocide going on. Max is another function that will take the other extreme. So this is Japan, I happen to know, probably in 2007. And then R has a function called range that returns those two numbers to you packaged as a vector of length 2. But this is the like remind yourself of functions, play with it. Also start to get a sense for the correct answer, because it often really helps as you develop a function to have like an informal test going all the time. You know what the answer should be. So I can take the max minus the min, and you should basically memorize this number because we're going to look at it a lot for the next 2 hours. So it's about 60 or 59 years is the difference in this data set between the max minus the min. I could use that result from range to do the same thing. So I could compute the range, take the second element, subtract the same thing, take the first element. Or if you've been using R even longer, you know that there's a function that takes adjacent differences. And so this is what I mean by play. So you play, you get something that works in a specific example. So that's step one. And the reason we want to do it this way, instead of just going straight to writing a glorious function, is illustrated by this graphic. It's pretty well known on the web and in software development circles. So it's called How to Build a Minimum Viable Product. So minimum viable product is a really great sort of policy for how to work. And so what they're contrasting on the top is if your goal is to build a car, it's tempting to build like the very best wheel, and then to build a second wheel, but you still can't go anywhere, right? And then you build the body of the car, but you still can't go anywhere. And only at the last minute, when you've succeeded at all of those things, do you have a car that you could maybe drive. But it turns out a much more productive workflow is kind of to force yourself to finish the job, even in a really like lame, hacky way, and then upgrade as you go. But so you should build a skateboard, but at least you can get somewhere. And then you build a scooter, and then a bike, and then a motorcycle, and finally a car, because it turns out you end up with a better car for having tested it. And I also find that from a psychology point of view and a morale point of view, moving from tiny success to tiny success is so much more motivating than I have a great wheel, one day I will have a car. I have a great rear view mirror, one day I will have a car. So just from a psychology point of view, this is really useful. And there's a famous saying from just general science world, the telescope rule. If you're trying to make a 6-inch mirror as part of a telescope, it is faster to make a 4-inch mirror and then a 6-inch than to just try to go straight to the 6-inch. So finding minimum viable product and then gradually upgrading that tends to be a better strategy for building lots and lots of things. And we're going to do that even with our tiny little function. So we're about to build our skateboard. So we're going to write our first function. And the way we do this is we take the existing logic that we know works and drop it into the body of a function. So you need to name your function. I'm calling mine max minus min, just because I think it's great. It's kind of long, but it tells us exactly what it does. And so max minus min gets is how I pronounce that assignment operator in my head. It's going to be a function with one argument that I call x. X is the traditional name. You can call it anything you want, but x, I would use x unless you have a reason to do otherwise. And I'm going to take, well, let me actually model often what this looks like, is you literally copy pieces of code that have been proven to work. This is the copy and paste you're allowed to do. You take working code and you drop it in. So here's the hard part, and that you often don't get the first time, is now you have to go find all the places where you had gapminder life expectancy and replace them with x. But that is literally what this often looks like, is copying working code into the body of a function. So now I'm going to send those 3 lines to the R process and define max minus min. My global environment shows that I've now defined my first object in this session, and it's a function. And so the very first thing I do is I call it on the same data I've been using to practice on, and I should see the same answer I've been getting for the last 20 minutes. And again, we're going to formalize this before we're done with something that's called unit testing. But this is what I call eyeballometric testing, where you're just kind of used to seeing 59.004, and that's what makes us feel like we're still on track, is that we keep seeing the same answer. Okay, so that's our skateboard. We've written our first function, and we're going to explore ways to make this function fancier and generalize it. Okay? So the first thing I'd like you to do, and I'm going to pause again and stop talking for a moment for you to do this, is try out your new function on new inputs. Okay? So we have reason to believe that it's doing what we want it to do, but so now you need to throw some other things in as X, and it should generally be something where you basically know what the max minus the min should be, so that you can sanity test it and give it a little bit of a workout. So again, I'll take a moment to be typing. If you just want to watch me type, that's fine, but I would encourage you to do a little typing on your own.
La misma, la última que el 59. Ah, y lo que pasa es que la idea, bueno, para ver si lo estás haciendo bien. Pero la maestra. Ay, después al cambio. Primero reinicia la otra. Tampoco puedes.
Okay, so you'll see that I tried my function on the integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because I can take 10 and subtract 1 in my head, and I know that I should get 9, and I do. And then a slightly more sophisticated little test is I know how to generate 1,000 numbers between 0 and 1 in R. So what should the difference, what should the max minus min here be? Or what do I know about it? Yeah, it should be about 1, because, well, it can't be any bigger, right? Because nothing will be bigger than 1 and nothing will be smaller than 0. And because I'm taking 1,000 of them, I should have some numbers that are pretty close to 1 and some that are pretty close to 0. So I expect this to be awfully close to 1, but not quite. And so this also illustrates, like, I'm deliberately throwing data at my function where I know exactly what the answer should be. And then I'm throwing bigger, more realistic data, random data at my function where I know approximately what the answer should be. Then, because I have the Gapminder data frame loaded, I apply it to another numeric variable. I get kind of a shocking answer, but it's also good to apply it to real data, if possible, that the highest GDP per capita somewhere, I happen to know it's Kuwait, is, you know, well over $100,000 per year. This is per person, this is average. And that there must be somewhere where it's almost $0, you know, it's hundreds of dollars. And so the max minus the min is 113,000. And then I know that this data set only goes from 2007 to 1952, so I know this has to be 55. But so this is what I mean by, now that you think your function's working, like give it a little bit of a workout. I think it looks pretty good. And then I want to, at this point now, we have enough code built up that I want to show you. If your transcript, the code you're typing, and then if you copy mine as we go or at the end, I'm deliberately formatting this in a way that if you're in RStudio and you click that notebook button, that will run the code and create a really nice looking document. So this is literally everything we've just done. So you can turn our scripts into you know, really nice looking. It's basically, I mean, R Markdown and .r, it turns out, are very similar. So I'm just typing my comments in a special way. Okay. So now I'm going to try to break my function. So I'm going to start applying it to things it's not really supposed to be applied to. But this is what real users do to functions. And this is what you will do to your function 2 weeks later when you don't remember having written it. So try your new function on weird input. So you can generate your own weird input. I'm gonna sort of talk live here. I'm gonna try max minus min applied to just the Gapminder data set. So you might expect this to work because some things do work on a data frame and they just go variable to variable. So we wrote this function, we know it's not that fancy, but your colleague might not know that. So sure enough, it doesn't work. We don't get the world's greatest error message. So we're gonna work very soon on writing good error messages and catching nonsense input. What if we apply it to character or a fact? This is a factor. Again, R slaps our hands because we're not supposed to be taking the maximum of a factor. So that doesn't work. What if we just apply it to a string? We also get an error because we're trying to take max minus min. Well, I don't know, that's a terrible error message. So the other thing I really wanted to show with these error messages is if you got that late at night before a deadline, do you even really know like what to fix? Like it's not saying you provided character input. It's saying, and which that is our problem. It's saying non-numeric argument to binary operator. Like, so one of the kindest things you can do to yourself when you write a function is to worry about your error messages and to try to help people when they give you bad input to tell them how they can fix it. So that's what we'll work on in just a moment. Now, if we did this in a longer format, I would challenge you. You would be suggesting weird input for me, but I will go ahead and cheat a little. So things that other students have discovered that are a little scary. Let me just show you some things that don't create an error. So I applied our function to the whole data frame and that didn't work. But if I apply it to a data frame with just life expectancy, GDP per capita, and population, I just get a number. So why does that happen?
Like matrix and looks for.
Yeah. Max is like, well, she gave me a data frame, but they're all numbers because it's 3 numeric variables. I'll just take the maximum of them. So it's clearly taking like the population of China or something probably, or it's like the very largest number we have. And then it's going to take the smallest number we have, which is probably GDP per capita somewhere, and it's going to subtract them. Okay, so this is also scary, that we can put completely weird input in and not get an error. So these are the kinds of things we're going to work on next, that you're designing a function and you want to catch weird input and throw a nice error, and you want to catch weird input that should generate an error and not let it sort of keep going. Okay, so how do we check for weird input? All right, and this is called, argument checking or validity checking, or as long as you're realizing you're probably the idiot proofing, but trying to make the function so that it's really hard to do the wrong thing with it. So the first function, we're going to start writing many versions of this function now, and I'm going to shorten it to MMM. So I'm going to write a new version of max minus min. And then the first level error throwing function in R is called stop if not. Okay? And it does exactly what it says. It feels a little bit backwards, but you say something that should be true. It's called making an assertion. I assert that X should be numeric. So whatever X is, I should be able to evaluate is numeric on it, and I should get true. So let's get to know is numeric. So is numeric 1, true. Is numeric 1.5, true. Is numeric high, false. Is numeric gapminder, false. So this, I think, is a fairly good way for us to catch a lot of the nonsense on the way in. And so stop if not is numeric X. It's the first thing we do, and it's going to make sure that X is at least numeric. And that should catch, I think, basically everything frightening that we just played with early on. And then we have our existing max minus min logic. All right, so that's our new beautiful version of this function. So I'm gonna do some copy paste now. So let's go find a few things, and I'll show you some cool editor tricks too. Let's try it out. So I'm going to go collect all my calls and paste them down here. These should work. All right, I'm going to show you cool RStudio tricks. So on a Mac, if you hold down Alt and Command, oops, I hope oh gosh, I have to remember this. Does anyone remember the thing for multiple? Oh, here we go. Control and Alt. You can get multiple cursors. Okay. So there are a lot of tricks with sort of rectangular editing that you should learn in your editor of choice. Okay, so now I can cruise through these and make sure that I haven't broken anything. So when I apply my new function to life expectancy, I get 59.004. We're starting to get really familiar with that number. When I apply this to the numbers 1 through 10, I still get 9. When I apply it to random uniform numbers, I still get something close to 1, but not quite 1. And I get the same answers for GDP per capita and year. These should not work. So now I'm going to go find my bad input. Okay, so if I apply this function to the Gapminder data frame, it shouldn't work, right? Like we know this should not work. And it doesn't. But look at our error. No one really likes getting errors. But in this case, it's good news. So we say we're getting an error in the call MMM Gapminder. And it at least tells us is numeric X is not true. So this is much better than whatever nonsense we got last time. Fun X double square bracket I only defined in a data frame with all numeric variables. If we apply it to a factor, we get the same message, And so this is not the world's best error message, but I think it's a lot better than the ones we were getting earlier in the sense that you or your colleague working under stress might be able to figure out that, oh, this was supposed to have a numeric input. Then again, a lot of people don't read error messages, but I would say that stop if not is your entry level error message. And then I'm going to show you maybe right before we take a break, one last way if you really want to write a nice error message. You can work a little harder and make a nicer error message. So instead of doing stop if not, we can do if and check for what we think is gotta be true, and then we write the stop, and then we can write the message ourselves. So I'm gonna copy MMM, give it a 2, and edit it a little. If is numeric. That's not what I want. I want the opposite of that. So I'm going to use the exclamation mark, which turns trues into falses and falses into true. So it's called the negation operator. So if X is not numeric, stop. And this is where you get to express yourself creatively. Now I'm going to say I'm so sorry. But this function only works for a numeric input X. Please try again. Okay.
Very nice.
So I can define that and try it on one of my bad inputs. So again, we get an error. We're actually learning how to successfully throw errors. But I think this is really important when you're writing function. And it's going to give our error message. I am so sorry, but this function only works for numeric input. Please try again. And then I'll write one more version of that before we take a quick break. To be even more helpful, I'm going to tell the user what they did wrong, okay? So I am so sorry, this only works for numeric input. We're actually trying throughout the tidyverse to change the style of all of our error messages, but it's like a long project. But to always say, you know, I need this, but you gave me that, to really help people figure out where to make the change. So I'm going to say you have provided, you don't have to type all this, you can just watch me do it. An object of class and then we're going to take the class of X and the first component, because sometimes that's a vector. Okay, I'm going to define that. And now we have, I'm so sorry, this only works for numeric input. You have provided an objective class, tibblediff. That's what tibbles are. If I apply this to a string, I'm so sorry, this only works for numeric, you've provided an objective class character. If I apply it to a function, it complains that it's a function. But this is a really good template for an error message when you really care about the people reading your error message. So you say, you gave me this, so that helps them find where in their code they went wrong, like which argument was wrong, and then you say how to fix it. So we're saying you gave me a function, but I need a number, a numeric vector. All right, so why don't we take a pause there? It's 7:30. We have another hour is my impression. So we'll take a pretty brief, like 5-minute break. Get more to eat, get more to drink, use the washroom, whatever, and then we'll pick up here.
Did you update?
And I have saved. I'll refresh and convince myself this is working. Has anything ever appeared there?
Yeah, it did.
It has?
Yeah, it has.
Maybe I need to retype. Yeah. Okay. This is working and working.
Yeah, I think we have some problems with the internet connection. I'm not sure we need it. They had, I didn't have to, everyone. Okay. Yeah, I think that it's only if they want live access. Yeah, and they were like very. Oh, they were yeah, so that's probably why I caught it. I'm not very active. Ahorra mucho tiempo. ¡Qué bueno! No, es que, exacto, porque de repente es una forma de no cometer errores. Creo que hay una forma de pero controlar. Sí.
La R Markdown y de ahí después lo vamos a ver. Claro, nunca me acuerdo de esto. ¿Cómo abrir? Claro, cuando el propósito de atajar, ¿no? Sí, cuando abrís uno de esos. Sí, hay que hacerlo visible.
¿Van a ir a hackathons? Hay otro hackathon ahora en medicina, la semana que viene. En la Junta de Medicina, Laboratorio de Innovación. Dale, yo te paso. Habla con este feedback. Sí. Quiero ver esto porque no lo encuentro.
Aquí ahora, ¿no?
Casi 2 años total. Hay de todo, porque hay, no es tan rápido, pero igualmente mandan, qué sé yo. Hay uno que había hecho un análisis de todo un trabajo de, ¿cómo se llama? ¿Viste? Cuando tenés las redes neuronales que querés ver cómo representa la capa intermedia de tal cosa, etc.
Ah, ¿se puede ver eso?
Sí. Y entonces estaba, no me acuerdo, yo me acuerdo, no me acuerdo.
¿Está en el crear? Había el levité y esas cosas. No era para nada. Funciona. Total. No, yo soy médica. Sí. Hago investigación. Sí. Hice mi especialidad en clínica, después hice epidemiología. Ya hago investigación en la Chile. Pero nada, tema tranquilo. Pero no, yo voy a todo. Pero ustedes como
Okay, sorry for the world's shortest break, but we'll restart here just because we have a very compressed amount of time together. So I checked, and it does appear that the live code is updating. So, and I think most of you have gotten onto the internet so that you can copy paste from there, or know that when you go home, you'll be able to get at absolutely everything that I typed. So if we were doing like a very long form of this, we're about a third of the way through. So you can tell we're gonna go a little bit faster for the last 2/3. And some of it, maybe I will show you sort of some pre-baked things. But so what we did before the break was we played with a little bit of top level code until we had something that worked. We dropped that into the body of a function and convinced ourselves that it was still working. And then we tried to break our function and basically used those examples, positive and negative, to test the quality of our error message and sort of catching garbage on the way in. Because your debugging life is much happier if you can catch garbage yourself instead of letting it filter down and die of some really weird error that's very, very hard to debug. So having validity checks on your arguments at the top, you can go a little too crazy with it. Like sometimes that starts to take over your function. Like literally you'll have more error checking. That is normal actually, to have more error checking code than doing code, which is really depressing. But once you have a lot of functions and maybe they're inside a package, you start to take the error checking code and you make that a function and you put it somewhere else where you don't have to look at it very often. But I would say in general, checking validity of inputs is time well spent because it's debugging you won't have to do later. So I'm going to go back to a more basic version of our function. So it's that first MMM we wrote. I literally scrolled up and copied it in case you want to do the same. And we're going to keep the stop if not around as our basic mechanism for catching garbage. I don't want that long, flowery apology there in front of our face all the time. So I'm going to make sure that this is defined. And now I'm going to throw a new challenge at you. Okay, so we built a skateboard, but actually I wanted us to build this car. I'm not that interested in max minus min. I want us to have a function that can take the difference between any two quantiles. Okay, and we started with max minus min as a nice special case, but now we're going to generalize this function, and we're modeling this behavior of walk before you run, build a skateboard before you build a car. So we're going to go back to play with a little bit of code and data. So we can work together. I'll sort of talk over it, but what function do you use to compute quantiles in R, if you've ever done it? Quantile. So if I start typing quantile, I'll see that there is a function in R called quantile. So why don't I apply it to life expectancy and see what I get. So if you just apply the quantile function to a numeric vector, you get an answer back that has 5 numbers, and some of them look very familiar to us. The first one is 23.59. We've seen that before. That's the minimum. And the last one, 82, we've seen that before. That's the maximum. And then these are other very famous quantiles in the middle. So what's the 50% quantile, also known as the median? Exactly. So that's the number at the point where like half the data lies to the left and half the data lies to the right. And then slightly less famous are the 25% and the 75% quantiles, which are known as the first and third quartile often. So you're getting back this pretty famous like 5-number summary. And so so if I hadn't been using R as long, I might get the help on quantile at this point. I still read a lot of R documentation because I can't remember all the arguments to all of these functions. So, but I often like try something first and then read a little bit of documentation. So I need to take charge of those probabilities. Okay, so I need to actually add some more information here. And so this is the main way we're going to call that function. We're going to keep feeding life expectancy in as x, but I can specify the probs, which is what I want to do. And you can see here there are defaults given, and we're about to practice setting our own defaults. And this is why the function works even if you don't tell it what the probabilities are. It just sticks something reasonable in there so that it can give you an answer. So let's try that ourselves. So now play with quantile a little bit. Quantile, gapminder, life expectancy, probs equals. So 0, 1 is interesting to me because that's just doing the same thing that range did. And so another very useful strategy is to try to do the same thing 2 different ways and to like check yourself or check this against that. And I love to, again, convince myself that I know what I'm doing. Who doesn't? So quantile, if I ask for 0.5, I get this number 60. And if I remember my stats, that should be the same thing as the median. So I like to play with a function and again, sort of throw some things at it that I feel like I know what the answer should be, or I know 2 ways to do the same thing, just to build confidence. And maybe another thing that we'd like to look at is just get the 0.25 and 0.75 quantile. Do I have a typo? Okay. Okay, so we've played with a little bit of top level code. So now we need to take this and create a new, like more general version of our function using this information. And so this is, I'm going to model for you how I would start to write the next function is I think about what the arguments to my function are going to be. So my user is going to have to state the probabilities. And so we'll just start with something concrete, 0.25, 0.75. And then I would use the quantile function to compute quantiles. And then I'm going to take the maximum of the quantiles minus the minimum. I'm trying to reuse a lot of my existing logic. Quantiles. Okay. So I've just taken the difference between the 3rd quartile and the 1st quartile. So that's a famous statistic. Does anyone know the name for that? Yeah. And is there a function in R to compute this? Yes. There is a function for the IQR. So if I've done this correctly, I'm going to get the same answer. So this is what I mean by like keep trying to work examples where you can check yourself against something. So I feel pretty good that I now have like one complete example that totally works and it's agreeing with an external way of computing the same thing. So I'm ready to write my new best function. And so we're going to call it QDiff because it's a difference of quantiles. And I'm going to give you a hint. We're going to write a few versions of this. So I'm going to call it QDiff1 is going to be a function that takes primary argument x and probs. And then I'm going to copy all of this working code and paste it in. I actually don't need the probs because the user is going to provide that. This should not be gapminder life expectancy. It should be X. Probs, quantiles. All right, I like the look of this. So QDiff1 gets, it's going to be a new function with 2 inputs. X is the primary input and probs. And the first thing we'll do is use the built-in function quantile to get those quantiles. I'm assuming there's 2 of them, but we have not locked that down at all right now. Okay, it could, and then we're going to take the maximum minus the minimum. So I actually believe this will work. So what should we set the probs to be? Like, what if we want to check it against 59.004? What probabilities does that correspond to? Which quantile is the minimum? I think I hear it. Just say it louder.
0.
0. Yeah, 0. If we can kind of look it up here, the 0th quantile is our minimum, and the 100% or 1 quantile is our maximum. So if we put 0 and 1 here, get it. Oh, there. We get our usual answer, right? So this is what I mean by like ad nauseum, like keep computing the same thing. And then we've been exposed to IQR. So that's another nice example to work, and we're getting the same answer as the official answer. And so this is what I mean by, I think we've moved from like skateboard to motorcycle now, where we sort of worked a very special case, max minus min, and now we're going to be able to do this for any quantile. And so something I haven't talked about, but so why am I calling this X and why am I calling that probs? I'm going to do some quick typing that you do not have to type for yourself. It'll just be in the document. So you can call your function arguments anything you want. So I could call this Laura and Natty, right? And as long as I replace it in all the right places, oh, yeah. It still works, okay? But I will tell you, even though we really love Laura and Natty, that this is a terrible idea. So you can call your function arguments anything you want, but it turns out you're dealing with humans who have like a finite memory and finite attention span. And so first of all, you want your argument names to explain themselves, like what they are. So X is the only one that we all sort of get a pass on. Like that's very typical for the first argument. It doesn't really say what it is. But after that point, you usually want argument names to be very specific and self-explanatory. And you want them to be as predictable and consistent with the existing world as possible. And a lot of people do know the quantile function and that they know it has a probs argument. So I would say in this case, the only humane thing to do is for us to also call it probs, because it helps people guess. Either if they read the documentation for our function, at least they'll recognize what probs means. And if they don't read the documentation and they try to use our function by just flying by the seat of their pants and guessing, they might actually guess that probs is the name of the argument. So in general, I think it's a really good idea to talk about, to use the argument names that people expect or that explain themselves. And something I haven't talked about yet, and I haven't given you many chances to ask questions because we're on a bit of a time budget, but I know that someone did already remark on this. I don't know, does anyone find it strange that I haven't used return? Yes. So there is a function in R. So I'll just use this example since we're here. So I could explicitly apply the return function to the last line there in my function. But the primary convention in R, and this is just a convention, is that we generally don't do that. And at least that's the style that the group that brings you the tidyverse works in. And a lot of other people too, it's not just us. So our convention is that we let the result, like sometimes we really call it like we let it fall out the bottom. So a function by default returns the value of its last expression. And why do we not use explicit return? Because sometimes you want to return early. Like in a more complicated function, if something's true of the data, you might return early. And if that's not true, you might keep going and do more computation. And so in that situation, you must use return. And because that's so special, we want that to really catch someone's eye. And so if you see return all the time, you don't notice it. But if you never use the return function except for early returns, it basically means that people still recognize it as being really special, and it like really hits you in the middle of a function. There's a return statement. And so that's why a lot of people don't ever use explicit returns here in this position, because maybe you would stop noticing returns. And so we don't use them here because you don't need them, so that when we use them somewhere else, we pay attention. But you certainly can use them. Maybe I should say a little bit about that just so we've recorded it. So hold on a second. So you'll see me writing our materials live. I'll try to be brief so that this doesn't take too long. Okay. Okay, I think that recorded what we said. Okay. The next thing I want to talk about is setting default arguments. So that was really sweet that we could call quantile on the life expectancy, and it just sort of chose a few probabilities for us. So what happens if we call our function, I guess qdiff1 is what I want. What if we call qdiff1 on life expectancy with no probs? What do you think is going to happen? I think we're going to get an error. We better get an error. Oh, it's because we can't find qdiff1. Yeah, so this is the error I was expecting. Probs is missing with no default. And so another great kindness that you can do for yourself and for your users is try to make it possible for them to use a function without providing a lot of input. So we're going to make a new version of qdiff, and we're going to set default values for probs the same way that quantile did for us. We're going to sort of return the favor. So I think we must be up to qdiff3. I'm going to go, this is the kind of copy pasting you are allowed to do. Okay, so the way you set defaults is when you define the function, you actually give a default value for an argument. So I've decided that we are so familiar with max minus min, and that's what we did first, that by default, this function will compute the max minus the min. And if we call this new version without specifying probs, it works, and it takes the max minus the min. And so sort of morally, you have to decide if you're doing more harm or good when you set default values for things. So do you think it would make any sense to set a default value for X? I'm thinking no, right? Because you don't want to make up data for people. So usually the primary argument to functions typically does not have a default value. And of course, there are situations where there's no arguments and where it makes sense to do that, but usually no. Usually that first argument, the user has to pass in. And then the later arguments tend to be ways to refine the computation. They're more like options. And so in many cases, there is an intelligent default that you can set for things. And I think that's like fairly reasonable here. And so here's how you would actually set defaults. And so again, if we had longer time, but we're just going to do this mentally, our function has gotten a little more sophisticated. So let's just at least talk about this. So we're not going to do this because we're going to keep moving, but what are some of the things, if you sat down and you gave yourself 30 minutes to sort of make this nice, what would you be checking for now that our function has gotten a little more sophisticated?
The props.
Yes, the probs. That's a new argument. So what would you check about it?
Not below 0 or not. Yes, not negative or higher than 1.
So probs, I think you would want to make sure in 0, 1, numeric. That's kind of implied, but you'd probably make sure it is numeric and there. That might be the order. What else?
At least 2.
At least 2. So what do you want to do with 3? What if someone gives you 3? See, that's a judgment call because you're only going to take the difference between the max and the min. So should you err? So these are judgment calls, right? So if you want to just work, then you wouldn't err because you can still do it, but you're ignoring one of their inputs. So this would totally depend on the context, that whether you think they should be alerted to the fact that they asked for something that didn't really make sense, or you should just do it. Or you should do it and throw a message or throw a warning. Like, you could do it any of these ways. But these are some of the decisions you end up making. So we'll say check length. Maybe check of length 2. Definitely at least 2. There are other ways of writing this function that if you were given more time and you were writing more things yourself. Some people take the first quantile minus the second, or the second minus the first. And then you would also need to check that the probs were in order, like that it was the little one and then the big one, or the big one and the middle one. But you'll notice the way I wrote this, it works no matter what, because this is not my first rodeo. But so that's the kind of thing you might, if you wrote the function in a more fragile way, that would be another thing you'd have to check for. Or it's easier to just take care of it yourself, because I don't really care what order people give me their arguments in. Okay, so we have about 25 minutes left, and we'll move into our last these are some more advanced topics, again, to think about in the future. Okay, so I think this is the version I want to be at. Qdiff 3. I'm going to actually restore stop if not is numeric x. All right. Otherwise, I'm happy. Okay. So the next thing I want to talk about is NAs. So, clean data that you mostly see in examples, like, never has any missing data, but all data in the real world has NAs in it. And so we really need to explicitly worry about what's going to happen when people give data to our function that has NAs in it. And so we need to study what quantile does with NAs, because that's where we're going to sort of encounter a problem. So what about NAs? All right, so I'm going to create a copy of life expectancy that we can do a little bit of violence to. So Z is just getting us a copy of that vector of life expectancies, and I'm going to set the third element to NA. The Gapminder data itself has no NAs because I like to teach with it. But so we're going to make it a lot more realistic now. So if I apply quantile to this copy that has an NA in there because we put it there, you immediately get an error from quantile. Missing values and not a number is not allowed if na.rm equals false. So let's look at the help again. So at first we were just looking at X and probs, and now the harsh reality is setting in that we need to be quite explicit about what we want quantile to do with NAs. All right, so I'm going to create a new version of our function. We're going to increment to 4, and I'm going to say I'm totally cool with NAs. Just pretend like they're not there. Okay, so qdiff 4 applied to Z. This should work and give me the usual answer because the one data point that I replaced was neither the max nor the min. Okay. So how do you feel about this decision that I just made for every user of qdiff? Like, it's kind in some sense because the function like just works, but it means they could give a vector of length 100,000, and it could have 999,998 NAs, and they will get an answer. Okay. So this is generally not the R way. One of the biggest differences between R, well, and some other languages for doing data analysis is that, almost annoyingly so, but I think it's good, R is really careful about NA handling and really explicit about NA handling. So this feels good for a few minutes, but I actually think it would be a better design for this function for us to have an NA RM argument ourselves. And that's more what people will expect. So again, designing things to be what people expect is really important. Okay, so that's nice, but I think we should expose na.rm. So we're going to create another version of this function. We're going to increment to 5. I'm not a monster, so I'm going to call it na.rm. I'm not going to make up some new name for it. And instead of setting it to true, I'm going to pass whatever the user said down. Okay, so now I have something that works, but again, like, the user isn't having to sort of admit that they have NAs, right? Because I set the default value to true. But the most typical R behavior would be to follow the same defaults that people are used to from quantile and LM and like every other function they've ever used in R. So what I hope to demonstrate with this is NAs are important, and you should probably have explicit handling for them. You should let people toggle it instead of making the decision for them. And even if this isn't your favorite default, you have to have a really good reason to go against what sort of the R convention is in terms of people being able to use your functions well. The last argument that I'll show us adding is the mysterious ... argument. So how many people have noticed a function that takes ... in it before? Yes. You use these functions all the time. So if you've ever made... Yes.
How do you know what it's where's a good place to look for what's the default in our, like,
for any, well,
like in the NA,
you would,
what's the best way in our that you just said told us for NA handling, but what's a good?
You would look, I think, at a lot of summary.
Okay.
You would look at a lot of functions, but yeah, there's not like a document or anything that tells you
are pretty advanced, right?
Well, NA action. And you have to go read down here, blah, blah, blah. Yeah, you have to, you would do a bit of research looking at functions in the same space and try to figure out what is typical and what someone who uses all these functions will expect. That's the best answer. Okay, but here we have a good example right here. You see all these ... dots in mean. And let's go back to the one that's not what I meant to do. Or the, you know, the C function, the way you make a vector takes ... dots. So it's, in English we call that an ellipsis, and it's like a very specific formal constructed R. That's not like, and some things go here. It has a very technical meaning, and it gets used when you need to define a function, but you can't say at the moment of writing the function exactly what's going to come in. Because we can't hardwire this to X. What if people wanted to provide 3 things? Okay, X, Y, Z, but what about 5, 10? So this is a function that takes a variable number of arguments. So you have to use ... dots here. So this is a little more sophisticated to work with, but I wanted to just make sure that you have seen it. So the way I'm going to motivate it is a little weird. But so if we go back to the documentation for Quantile, it's got a few arguments that we haven't worked with yet. So in particular, it has a type argument. So if you take the median of 1, 2, 3, the median is 2, right? So anytime there's an odd number of objects, it's easy to compute the median because it's the middle one. But what is the median of 1, 2, 3, 4? It's probably between 2 and 3. What is the median of 1, 2, 3, 100? It's still between 2 and 3, but maybe it's closer to 3 because like the 100 is out there. So anyway, there are people who've written whole PhD theses on how to make this decision. So whenever a quantile cannot be like uniquely assigned to one of the observed values, it means you have to interpolate between 2 of the values. And there's a lot of different ways to do that. And that's what the type argument controls. And I have now told you everything I know about the type argument. I don't really care about the type argument. I just want to show you an example of a piece of information the user might want to provide to our function, but probably not very often because not many people care about the type. And so I want to make that possible for them, but I don't want to actually build it into my function. So I'm going to show you the use of the ellipsis. All right, so it feels like magic, right? So I've added ... dots to the definition of my function, and I've added it to my call to quantiles. And we're about to prove, and maybe we'll explore this a little bit, we'll sort of back up a bit, but this allows someone to provide the type argument if they want to, but they don't have to. So if I do qdiff6, Gapminder, life expectancy, that should just work. Now, the sad fact is that the difference between these types is incredibly subtle. And so I think to actually show you the difference, I have an example cooked up. We're going to have to use some fake data for you to even believe that anything's happening here. So I'm going to generate 10 random normal variates. And let's see if we can see the difference. qdiff6 on C. Let's see. Maybe this will be sensitive enough to tell us. I'm sort of I have like a bigger example. All right. This is what's annoying about the types. All right, well, once you see the materials, you can create fake data where the type actually matters. But so let me just leave this as a somewhat theoretical example that this is how you can make your function more general, but without cluttering your interface with like every argument under the sun. And just like a tiny function I can write for you to show you what's going on. This feels like it does nothing, right? I've written a function called f that takes this weird argument ellipsis and it drops that into a list and returns it. But look what it does. Like it takes arbitrary input and lets it drop right out the bottom as a named list. And so I just want that to be in your example for you to realize that something is actually going on there, that the type argument is being accepted from the user and passed down into quantile. Okay, so I think the last thing I will say is, okay, so we've blitzed through a lot of writing functions and sort of function design questions. So the last thing I'll talk about is testing. So we've been doing informal tests all along, right? So we computed the max minus the min, it was 59.004. We were sort of informally always making sure we got that same answer. Or we would check ourselves against IQR or like some function that happens to be lying around. But once a function becomes a fairly important part of your life, you probably want to get more formal about that. And so in software engineering, this is called unit testing. And if you had a bunch of functions and you put them together in a package, that would be a hallmark of quality, that the package had unit tests. And a development habit in the R world increasingly is for people to report their test coverage on like the GitHub page where a package is developed. So this is the GitHub page for Tibble. Currently it is failing on Windows, but this badge here, CodeCov, where it says 90%, that says every time anyone makes a change to Tibble and the package gets checked formally by our command check, that 90% of the lines of code in the package are hit by at least one unit test. And that's what these numbers are talking about. Here's read Excel, it's passing, and it's got 92% coverage. But so that's what those numbers mean. If you ever look at a package's web page, and it doesn't mean that everything's correct, because users can throw much more challenging data at your function and your package than you can ever dream up. But it's your first line of defense. And so we will quickly talk about testing, and then we will be done. So this is the kind of thing where certain patterns come up so often that you generally don't want to write your tests completely by hand from scratch. And almost in every language, there are what are called testing suites, or like packages that help you write tests. So the one I'm going to use, and that is the most common one in R, is called TestThat. And it gives us kind of some helper functions. And in particular, it has tons of functions that start with expect. Expect condition, expect equal to reference, expect error, expect false. And so the way you use these functions is you execute your function with a known input, and then you state what you think should happen. Okay? So for our case, so qdiff, the last version of this we wrote was qdiff6. And one example of something I know about this function is that it should error for input that's not numeric. So I'm going to write expect error, and here's where I write a call to my function. So if I call it on nope, 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 it should error. And I say I expect error, I execute that, nothing happens. You can even be more specific. What is the error? Is numeric is not true. Hopefully that works. No, of course not. So you will notice if you look in the test suite of packages that you know and love, you will see statement after statement after statement like this, where you put good data in and you know exactly what the answer should be, and you put bad data in, you know exactly what the answer should be. So an example of a good, of a positive test might be expect equal qdiff6 1, 2, 0, 1. So what do we expect the answer to that to be? One. And so this looks painstaking. You can see why you don't do this for functions that you write casually. But so you would build up huge suites of tests, And of course, you don't check it for every possible value, but you just try to get a bunch of sanity tests down for every function that's really, really important. Where you have some bad input, make sure you catch it. You have some good input, make sure it does what you expect. Another test we did informally, expect true QDiff R norm, sorry, R unif. If I generate 10 random variates and I do max minus min, this should be less than 1. Except I've got too many parentheses somewhere. There. Okay, and so this is me taking our eyeball-o-metric tests from earlier and starting to make them formal. All right, and I think that brings us to the end with 4 minutes to spare. Oh.
One example where that will fail.
What?
Like a test would not.
Oh yeah. So yeah, I do have I have a canned example of how I want to fail. So let me do that.
That takes too long.
No, it doesn't. It's not that long. Yeah, this should be quick. So let's break things and see if we could detect it. So let's make one final version of QDiff 7 where we don't handle NAs. Let's go back to something much simpler. So QDiff 7 is actually something we made earlier. So it would catch non-numeric input, but otherwise it's very simple. Expect, and then I'll modify that test. So if I throw data with an NA, and I haven't accounted for NAs, this is not going to be 1. This will be an error. And so, but that's not the, hold on. This is a little goofy. The way you say that you're expecting not an error is to say that you expect error but NA. But so this is an example of I asserted that I should not get an error, but I am getting an error. So that's what a failed test would look like. And when I happen to be working in the reprex package right here in terms of where I've been typing. So every time I make changes in the reprex package, I run the test. And this, every time it's incrementing, it's running like one of those little expectations that you just saw. And I'm going to pass test here because I believe, because the package is in a functional state right now. But so if one of those failed, if one of my expectations was not true, you'd get like a big red X there and it would show up in this report. And so this is crucial if you're actually building whole packages of functions, so that you can't possibly keep in your mind how your whole package works at once. But you need to go tinker here and fix that and add a feature there. And so having it well tested is really, really important because it's very liberating. It means you can work on some parts of your package and some functions and have a reasonable confidence that you aren't breaking other things at the same time. So that's why you want tests, and then you run this sort of thing maniacally as you're making changes to your package. Yeah, is there any other question like that? Yeah.
Where do you place those tests in the package? Like within the function?
Nope. So here we are. This is the actual file structure for the reprex package. It doesn't really matter what package it is. And it is typical to have a directory called tests. And then for people who use test that, there's always a script called test that. That's typically very simple. And then here's where all the test files are. And it's just tons of test that, expect that, test that, expect that, test that. And so it was, that report you just saw was just like working its way through all of those files. And if you're working on a package, there's a package that helps you make packages called Use This. And it's really part of DevTools, or DevTools is getting broken into smaller pieces, and Use This is one of them. And it has a few helper functions. Use This, use test that would set up that directory for you and put that script in for you. And then once you have that set up, use test would create new test files for you. So this helps you get started with that pattern. If I execute it here, you know, it's going to offer to overwrite my existing test infrastructure, so I'll decline. But if it wasn't there, it would initiate like putting things in the right places, and it would put like one dummy test, which is like expect that 1 = 1 or something, just so you have something, and then you start adding them as you go.
How do you know you're done testing? Do you ever know you're done?
No. And sometimes people get a little obsessed with getting to 100%. And I won't say that that's ever bad, but you'll, by chance, right, the two examples we looked at had 90 and 92% test coverage. Use This itself is much lower. It has 61%, and see how they color code it to make you feel bad? But that's because a lot of Use This functions call the internet and create Git repositories and stuff that's very hard to test. So there's no magic number, but the reporting systems totally incentivize you to get over, like the colors get better and better as you get over certain thresholds. So some people do try to get to 100%, and I mean, I'm sure that's great. And every time you write tests, you always find a bug, like it's really amazing. But I don't have like a specific number that I aim for. And yeah, in fact, once you're using all of these automated systems, as you go, like you'll notice that this build of Use This technically failed. It passed tests, but it dinged me because my test coverage went down like by 1 line or something like that. So there's all sorts of things telling you constantly how you're doing about increasing or decreasing your test coverage. Once you have, you know, like a bunch of functions in a package and are sort of monitoring it over time. Any other questions?
I'm sorry if I bring it back to something and it's a very beginner's question, yeah. But you mentioned the use of the return function in the code. What about the last expression being an assignment or wanting multiple outputs? Is that a...
Okay, that's a good question. So it can be an assignment. So if you, where are we? Assign inside your function, y gets x times 2, f of 2. You don't see anything, but 4 still came back invisibly. So if you make an assignment inside your function, that value 4 still falls out the bottom. Maybe it's easier to see if I, but it has the effect of making it invisible. And this world where y existed only existed for the length of time that f was executing. So like y has not been left behind here for me, but z has. So if you want to store a value, you've got to assign the output of the function to a value, in this case in your global workspace. And if you want to return multiple things, you have to smush them together into some object. So f is a function of x. I don't have to return them in a list in this case, but you have to shove them together. You can only return one thing from a function. And so the reason I showed you list is sometimes the things you need to return can't be placed into a vector. I don't, like if for some reason I wanted to return, just like humor me, you know, I can't put 9 and cow in a numeric vector or in a character vector. I have to return a list. So usually when you need to return multiple objects, a really common thing you do is you make a list and you just throw everything in there, maybe with good names. You assign that every time you call it, and then you pick the stuff you need back out of it again. Okay, so I'll end here. So I will add a few comments at the end so that you know what those random things I was doing at the end were about. And what we went through are, there's a sort of, at a much more leisurely pace in this course I have taught, we have sort of a 3-lecture series of writing functions. And you did actually see it all, but at a blistering pace. So if you wanted to read those things in a more calm fashion and see sort of more links out to other resources, if you go to stat545.com and you look at the topics, you'll see that there are 3 lessons on writing functions. So you don't need to capture these URLs really. But so everything we did is there in a nice clean form. And then you'll have the ugly but realistic transcript of everything that we did together if you capture the state of this file tonight sometime. And it'll sit there for weeks or months because I don't teach again until October. So there's no rush. And without further ado, thank you again for having me. And I will linger around a bit at the end if you want to ask more questions or chat about other things. It doesn't have to be about functions. I'd be happy to answer more. Thanks.
Thank you very much, Jenny.
Okay, I have one. This is the last thing you said. If you check someone else's package,